Hello, CS111 students. I'm recording this video to help break down the problem set for you and do a thorough description of each task. This is the video for the bug hunt task in problem set 1. And I'm going to start this video actually by showing you how to get to the problem set page from the main web page of the class. This is the very first problem set. And the content of this video is going to be the same as what's written in the problem set description. So you can feel free to just read that description. You do not have to watch this video. But if you prefer to listen to me talk about it and think that that's helpful to understand the problem, then this is the alternate format for that information. So here we are at the main website for the class. And if I click on the schedule link here, it will take me to the calendar for the class. And this is basically where all the links are for lectures, labs, problem sets, everything is here. When a problem set is published, right? And so like problem set 2 will be published this Thursday. Generally speaking, it's the end of the day. So Friday morning it should be available. Then in the calendar it'll be a link. And you can see that problem set 1 is a link. Both PSO1 out and PSO1 do, they're both links. If I click on those, that will go to the problem set page where it has a description of all of the relevant readings, including the lectures, labs, chapters of the textbook that are all relevant. So those are all collected here. And then there's a brief description of each task. There's a time estimate that tells you how long it might take for you to do this based on the time estimates that you will be providing us when you submit the task. There are links to the task with rubrics here, and there's a detailed description of how to turn things in. And especially for this task, pay attention to all these instructions and follow them. I'm not going to go into them in this video because we're focused just on task 1. So before I go to the task, I'm actually going to open that rubric in a separate window, and we'll check that out in a second. But here's the page for an individual task. This is the bug hunt task, and this video is going to walk you through everything that's on this page. So first, there's also a link to the rubric at the top. Let's check that out. The rubric is a detailed breakdown of how we will be grading your submission, and the grading is automatic, which means that you basically have to do all the things that it says and do them pretty precisely for it to work. There is a chance to revise your problem set submission if something doesn't go as planned. And you can see that in the course policies, which again, I'm not going to go into now. But this rubric for task 1, the bug hunting task, it has different sections of it. There's instructions requirements, behavior requirements, and there are blue and yellow parts that are labeled as core goals and extra goals. So the different sections are to help you understand what the requirement is talking about. Here, this top section is talking about what code you write. And then this bottom section is talking about what the code does, which is an interesting and kind of important distinction that we'll be getting into more as we go along in the class. But you can see that for this task, the requirements are fix bug number 1, 2, 3, 4, and there are hints here. So it's always a good idea to check out the rubric for a task before we actually dive into it, because oftentimes there's some hints in the rubric about how to approach the task or what you should be doing. I'm going to go ahead and jump into the task description now. So this is the very first task and the very first problem set of the course. And we know that for some of you, this is the first time you've ever done any coding. So part of our first problem set is to, instead of asking you to write a bunch of code from scratch without knowing what that means or what that looks like, we're, for this task, giving you some code. It's code that doesn't work, and your job is merely to fix it. That's not necessarily an easier job than writing code from scratch. It's harder in some ways. But this idea of debugging or taking code that doesn't quite work and improving it until it does work is a really important skill in this class, and something you'll be doing on every task as you write code yourself. So for this first task, we're giving you a piece of code that is supposed to do a certain thing. It doesn't work, your job is to fix it so it does what it's supposed to do. And in that process, you'll be playing around with different types and different operators and some built-in functions, all the basic stuff that we're learning this week. So this background section talks about the concept of debugging, which I just explained a little bit. And it has this example program, which has some bugs in it. So this example program says a variable username gets the result of function input with what is your name as the argument. That's how I read this first line here. We are calling a function called input. That's a built-in function, right? We know what it does. It's described in our slides for the class. And when we call a function, we have parentheses. And then inside the parentheses, we give that function some information to work with. In this case, a string, what is your name, which is telling it what to print out to show to the user so they know what to type as it is waiting for input. We're going to take the result of that, which will be what the user typed, and store it in this variable. Then we call another function on this next line of code. We say print hello username. Then we call input again here to ask the user to enter an integer and store that in a variable n. And then we call print again with multiple different values that we're printing. Notice here the color is a hint as to what's going on. So these quotation marks create strings, and those are in red. The values in black are not strings, they are variables or other values. The numbers get this like bluish color. So this program will do this when we run it. And you can copy paste this code into Thonny and click the run button and see for yourself and play around with it if you want. But this is an example. And in this example, the text that is being typed after I click the run button is in blue. The text that appears automatically because the program produced it is in black. So to get this output, you'll have to type in Wendy and then 23. And after each thing you type in, you hit enter. So this example output, right, it says hello username. It doesn't say hello Wendy. And it says 2 times n is 2,323, which I do not think is the correct result for multiplying the number 23 by 2. So those are bugs. Those are issues where this program doesn't behave as we might like it to. And it describes this here in the text and then talks about different ways to fix these. So for the first bug, the code here says hello username, and you can see this username is red. It's inside the quotation marks, which means it's part of the string, which means the program is being told to use the sequence of characters username, right, the literal word username. We would like it instead to use the value of this variable, right? That's why we stored this value in a variable, is to use it later in the program. That's what variables are for. So if we're going to store your name, we'd like to use it to say hello Wendy, for example, if that's what you type, or whatever you type, we'll say that back to you. To do that, right, we need to put the username as a variable outside of the quotation marks. And there's 2 ways to do that. We could use the plus operator to combine this string stored in a variable with this other string, which is not stored in a variable, but it's just something we specified directly. Or print has the option of having multiple arguments. So we could use a comma to say, hey, I want you to print these 2 things instead of, you know, this all gets combined into one thing before print even sees it. So there's 2 ways to fix that bug. And then there's 2 ways to fix this other bug. So instead of multiplying n by 2 and getting 46, what we're doing is we're repeating the string 2, 3 to get the string 2323, right? And that's because Python is treating the value n as a string rather than as a number, right? And this gets into the idea of types, that every value in Python has a type, and how operations occur on that value depends on its type. So the string 2, 3 and the number 23 are 2 different values, and in order for Python to understand that we mean the number 23, we have to tell it, hey, I want to convert this to an integer. There's different ways we could do that. When we ask for input, which by the way always returns a string, we could immediately convert it to an integer before storing it in the variable n. Or when we do the computation of 2 times that number, at that point we could convert it to an integer. Either of these is perfectly fine. So there's multiple ways to fix different bugs, but in the end we want the output to look something like this. So that's just an example to illustrate what a bug is and what fixing it might look like. Your job is to do that process to all of the 12 bugs in the program we've given you. Okay, there's a note on print here in the problem set, or in the task. I'm not going to read into this now, but I'll come back to it at the end of the video. And just as a hint, you can click these minus signs to kind of close sections of the problem set that you are not interested in right now. And then click them again to expand it. So I'm going to go straight to this other section. We've given you a file called mathpractice.py. And by giving you that file, we mean we've put it in the download directory so that you can use your CS account via CyberDuck to download it. We'll show you how to do that in the lab. Here are two examples of what the output should look like, again, with things typed by the user in blue. The idea of this program is that it's a simple program using all of the concepts you learn in this first week that is used to do like practice for, say, an elementary school kid of math. So you can type in two numbers and then it'll ask you, hey, what's the result of adding them and subtracting them and multiplying them and dividing them? And each time it'll print out the correct result so you can compare your answer with the correct result. It doesn't do anything like check if you're correct and say if you're right or wrong. That would require some concepts in programming that we haven't quite learned yet. So this is what the program is supposed to do, right? And you can read this text in detail on your own. Here's another example, right? Depending on the numbers you put in at the start, it changes the numbers that are printed by the program later on. Although note that these other inputs, as the user sort of guesses the answer to each question, they don't matter. We don't pay attention to them. They don't affect what result is shown. We always just show the right answer, whether or not that was what somebody put in. Okay, so we gave you this program. Here's what it's supposed to do. It doesn't do that. Your job is to fix it. And we're not telling you much more than that, other than the hints that are in the rubric. So it's up to you to figure out why does it not do what it is supposed to do and how to fix it. And at the start, if you just click run, you'll get an error message, right? And that error message is Python telling you something about what is wrong. Try to figure out what that error message means, and then the error message will name a line of code. And that can be really helpful in going there and fixing things. Once you have fixed a few errors, you might get to a point where there are no more error messages. But if you carefully check the different parts of the code, you'll find that actually there are some differences between what it should print and what it does print. And for the more elusive bugs, you might even have to test it with different kinds of values here. It might be the case that it works most of the time, but it doesn't work all of the time. And in addition to just testing it blindly, you can also think about the code that's there and look at it and reason about it and look at what it's supposed to print and ask yourself, well, is that the right operation for that, right? Am I multiplying when it says I should be multiplying? Things like that. So there's some notes here. The first one gives you a sort of pretty big hint. So most of the changes require modifying or replacing existing lines in the program. It is actually never necessary to completely remove any lines of the program. It's also not necessary to add any new lines to the program, although there's some places where you might have to write code on a line that was a blank beforehand. So we're not asking you to completely rewrite this thing and change things around and remove and add things. We kept this problem fairly constrained. The next note says you should use an incremental strategy for debugging. Incremental, right, means step by step. So basically, find the first thing that's broken, right? Starting from the top, is there an error message? If there's an error message, focus on that. If you've gotten it to the point where there's no error messages, what's the first thing that you can see that's just not quite right? And don't worry about fixing everything at once. Try to fix that one thing and then run it again, right? And keep repeating that process until you can fix everything. That's much better than trying to fix many, many different things at once because it will keep you focused on one thing at a time. And sometimes when you fix one thing, it actually changes what other things do. So a fix in one place might cause issues in another. And if you try to fix multiple things at once, that can make things harder. It's also the case, if we look at the rubric for a second here, that the bugs are numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You'll notice that 9, 11, and 12 are extra goals. And those numbers are actually the same order that the bugs appear in the file. So, for example, this bug number 9, which is an extra goal, is something that is between bugs number 8 and 10 in terms of where it appears in the file, which line you need to change. And so using the ordering here of the hints should help you even more to figure out what's going on. Okay, other notes here. There's an assistant feature in Thonny that shows up on the right-hand side. It's a little bar labeled assistant, and it will give you some extra tips about errors that are occurring in your program and what you might do to solve them. The assistant isn't all-powerful. It's not going to actually, tell you everything about all the bugs. It's not going to tell you how to fix them necessarily. But it's a useful tool for helping to find them. And if it talks about something on a certain line of code that says, maybe this isn't right, pay attention to that and see if that's potentially a bug. And then the last note here is there are some bugs, right, that Thonny can't, the assistant can't see, that don't cause an error message, right, where as far as Python knows, the program is doing something reasonable. But as far as a human can tell, maybe it has the wrong answer when we're trying to multiply two numbers, right? And maybe that's because it's using addition instead of multiplication or something like that. And so you're going to have to check whether the output looks exactly correct to fix the errors that are displayed. There's a link that we give you in task 3 of this problem set to a website for checking differences. You could go to that website and paste in these examples and then recreate these examples yourself by running the code that you have in Thonny and use that to find any little differences between them if you really want, although it's not necessary if you just look at things carefully. So that's the video for problem set 1, task 1. I hope this is helpful, and yeah, hopefully this is a fun thing to do in some ways to hunt down these bugs and figure out what's wrong with this program that we've given you. There will be further videos for the other tasks in this problem set.